Alright, today we're going to be looking at the u-substitution method for solving integrals. The way we can think of this is typically we can think of it as doing the chain rule backwards. Not all the time, but in our case, just to begin with, we're going to think of it as a chain rule backwards. So to introduce this topic, well, why don't we start with doing the chain rule. So let's say that we take the derivative, so d over dx, of a function f composed with a function g. Okay, now remember, if we're doing the chain rule, that's going to be the derivative of the outside, leave that inside alone, times the derivative of the inside function. Now remember that derivatives are undone by integrals. So if I take the integral of this guy, what I should get back is this guy on the left. That is, that the antiderivative of f prime of g of x times g prime of x. Well, if I take the antiderivative of this, what I should get back is that original function I took the derivative of. So I should get back f of g of x. And remember, this isn't a definite integral, it doesn't have bounds, so don't forget we have to add the plus c. Now, to make this job just a little bit easier for us, what we are going to do is instead of calling it g of x, we are going to take this and we're going to say, hey, let that equal u. Okay? Now that's not enough, because if I replace this with u, well then what am I going to replace this stuff with? Because that's still in terms of x, and it'd be really cool if I didn't mix my variables together. So what we're going to do is that we're going to take the derivative of both sides with respect to x. So the derivative of u with respect to x is du over dx. Well, the derivative of g is just, well, g prime of x. Now what I'm going to do is see this dx in the denominator? I'm going to multiply both sides by that dx. So multiply both sides by dx. And what I'm going to get is that du equals g prime of x times dx. Which is great, because now what I can do is I can rewrite this entire thing in terms of u. So let's go ahead and rewrite this entire thing in terms of u. So this is going to be the integral of f prime of u, because remember, g of x, I set that equal to u, times, and now instead of g prime of x dx, well, I can just replace that with du. Now remember, the antiderivative cancels out that derivative, so what I get back is just f of u, which is so cool. I know I didn't have to write that, but I really do think that the u-substitution method is just the coolest thing ever. So let's take a whack at this, and let's do an example that, I don't know, is a little obvious to us, where like if you gave us enough time we could probably figure it out. So let's take a whack at an example. Let's see here. Let's do, let's do the antiderivative of cosine of x to the fifth times 5x to the fourth dx. Now, the first thing you're going to do when you're using the u-substitution method is you're going to figure out what's your inside function. So this 5x to the fourth, that's not inside anything. This x to the fifth, however, is inside this cosine function. So I'm going to let u equal x to the fifth, which means, now before I did the whole du over dx equals 5x to the fourth, etc., you can just take the derivative of both sides. So that's going to be du equals 5x to the fourth dx, which means I can substitute du for this entire bit. So what this turns into now is now I have the integral of cosine of, and remember, instead of x to the fifth, I'm going to have u, and instead of 5x to the fourth dx, I'm just going to have du. Which is much easier, because what's the antiderivative of cosine? Well, it's sine of u plus c. Now we have to be careful though here, because remember my original function was in terms of x, so my answer should be in terms of x. And that's not too bad, I just have to re-substitute in that x to the fifth. So my final answer is going to be sine of x to the fifth plus c. Now remember, you can check your work by taking the derivative.